so I don't have to write that out. Okay, so everybody got the zeros correct. The zeros are at -2, at 3, and at 7. So I'm going to put circles around those. These are my zeros. Okay? And I'm not going to label any other points on the axis because it'd be easy to confuse those with zeros. I'm just going to label my zeros, okay? Then, between -2 and 3, well, zeros between -2 and 3, right? So if I plug in 0, I have -3 and 2, -7. That's a negative, a positive, and a negative. And when I multiply 2 negatives and a positive, I'm going to get a positive. Everybody understand what I just did? I want to see all that when you do the homework. Because I know if you do all the homework and do this on every problem I ask you to do, you're going to have it. And we're not going to, you know, it usually takes people a couple of weeks before they even understand what we're doing here. Okay? Which is why I'm breaking it down to a specific set of steps. Now, once you've done it correctly on several problems, you'll understand it. Okay? And you'll be able to write it down really quickly. But sometimes you can, you know, if you're in a hurry, you can just kind of skip that. Yeah, that's going to be positive, that's going to be negative, right? But you want to do it carefully for right now. Okay, so between 3 and 7, well, I'm just going to reason it out, but you could pick like 4 and say, okay, 4 minus 3 is positive, 4 plus 2 is positive, 4 minus 7 is negative, so it's going to be negative, positive, positive, negative, right? Or you could say, well, x is more than 3 and less than 7, right? Yeah, maybe we're better off just picking a number, okay? Any number you pick between 3 and 7 is going to make this one positive, this one's going to be positive, and this one's going to be negative. So you're going to have a negative, and we're going to put that circled minus sign below the axis, just so we kind of get a visual picture where the graph's going to be. Okay? Okay, then if x is bigger than 7, we don't really have to pick a number. If x is bigger than 7, you know when you subtract 3 from it, it's going to be positive. You know when you add 2, it's going to be positive. And if it's bigger than 7, subtracting 7, it's still going to end up positive, right? So we know we have here positive, 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 which is a big old positive. Okay, over here, well, less than -2, well, it's going to be negative, so x minus 3 and x minus 7 will both be negative, right? If x is negative. And if x is less than -2, then when you add 2 to it, it's still going to be negative, right? Now, if you wanted to, you could pick -3. Okay, -3 minus 3 is -6. -3 plus 2 is -1. -3 minus 7 is -10, right? So it's not difficult to see that. We're going to have 3 minuses, which means it's going to be negative. Okay? Now, the only other thing we've got to do is check what happens if x gets really big, either if we go a long ways that way or a long ways that way, right? Well, you can think, as long as x is a lot more than the value, the x value at the last 0, okay? So wherever the last 0 is, you go maybe 10 times that far. That'd be 70, but we'll round that off to 100 and use 100 again. So you're going to have something pretty close to 100, something pretty close to 100, something pretty close to 100, right? They're all positive. And they get really big, because you multiply a big number by a big number, you get a much bigger number. Multiply that by a big number, and you get a much more bigger, humongous type number. So we know that the thing does this. Now you read your text, you read about end behavior. That's all they're talking about. They'll say it differently than I do. Not nearly as well, but they'll say it. Okay? Now, over here, if x is like negative 100, you'd have like negative 100, negative 100, negative 100, right? Okay? Well, that's three negatives. Clearly, if x is less than negative 2, these are all negative, and if x is a number really far along the line, all those negative numbers will be big negative numbers, right? So when you multiply them, you're going to get a huge negative number, and they get negative more and more rapidly. So we draw the graph. Okay, we're starting from big negative numbers. And then we're going positive, now we're going negative, and now we're going big positive numbers. That's a reasonable graph. Not as smooth as it ought to be. The board's a little rough, and I'm a little bit uncoordinated. So, okay, makes sense? Anything difficult about that? So learn to do it. It'll save you a lot of trouble. Okay? Get it now. Don't put it off. You're going to have to do it on the midterm. Okay? Now there's another thing, rational functions. Let's say we have this. R of x equals x minus 3 times x plus 2 divided by x minus 7. Same factors I had here, except one of them's in the denominator, right? So it's not really a factor. If x is close to 7, then x minus 7 is close to 0, right? Now if x is 7, this is 0, and your division isn't even defined, right? Okay? So what we can say immediately is we have zeros. If x is negative 2, or if x is 3, I don't want to go that far. If x is 3, these are zeros. But when x is 7, in the first place, the whole function is undefined, because that would make the denominator 0, right? So if x is 7, our function is undefined. Okay? And it means there's a big old hole in the function. And a lot of times what you get, and you do in this case, is you get a vertical asymptote. You tend to when your denominator is 0, unless your numerator is also 0. So I'm going to go ahead and draw a vertical line. And that's going to be the vertical line x equals 7. Now, there are two things. If you remember, when we graphed like 1 over x or 1 over x squared, the function is undefined at 0, and we don't cross x equals 0 when we do the graph. So we get a graph that's like this on one side and like this on the other, and they don't do this. This doesn't come up to here, and this goes down to here, and then they wiggle around and somehow go through the axis. It's not what happens. Now we'll talk about that behavior a little bit, because for some reason it's somewhat difficult for people to grasp. I think it's because when you get down to it, division by small numbers is difficult for people to grasp. Even more so since people don't actually divide by small numbers. They punch things into calculators and don't understand what the implications are. So we'll need to talk about that. But it's always been kind of tricky for people to understand, even before calculators took over. Can't blame it all on calculators. It's basically a hard concept, apparently. Okay, well, anyhow, we know that the graph has to go through this and this. okay? We're going to find out that the graph has to have an asymptote here, but whatever. The graph is going to do something up to this line, and then it's going to do something else on the other side. Just like 1 over x squared. It does this on one side, and then it does this on the other side, right? Or like 1 over x. It does this on one side and this on the other side. Asymptotes will do that, vertical asymptotes. They'll behave one of those two ways. So you already know what they look like. Okay? Okay, so we still use the same reasoning. It doesn't matter if you multiply or divide positive and negative numbers. The rule is still the same, right? If you multiply a negative by a positive, it's the same as if you multiplied a positive by a positive, then divided by a negative. It's going to give you a negative, right? Because division is nothing but multiplication by the reciprocal. And if the reciprocal is negative, so is the number, okay? So we can still do exactly the same thing we did over here. And actually, since I used the same factors, everything's going to look exactly the same, okay? We're going to have a negative, positive, negative here. Like if we choose x equals 0, we're going to get negative 3 times 2 over negative 7. You don't have to calculate that to see that it's going to be positive, right? Two negatives and a positive. Doesn't matter whether you're multiplying or dividing. Okay? So the signs are going to be the same. Between 3 and 7, we're again going to get plus, plus, minus. From 7 on, we're going to get plus, plus, plus. And from negative 2 to the left, we're going to get minus, minus, minus. So we're going to be negative here. We're going to be positive here. We're going to be negative here. And we're going to be positive here. Okay? It's exactly the same reasoning whether we're multiplying or dividing. Okay? Make sense? So this part of the process is always identical. Okay, well, next question is, what about the end behavior? Well, if x is 100, what's this going to be close to? Well, this is going to be like 100, this is going to be like 100, this is going to be like 100. Yeah, close. If I got 100 times 100 divided by 100, what do I get?
About 100.
Pardon?
Around 100.
Yeah, you get around 100. Sounded like you said 500. I knew you knew better, so I had to ask you to repeat it. Okay? That's my ears. Okay, so 100 times 100 divided by 100. Well, 100 divided by 100 is 1. Leaves you with 100, right? Okay? Well, that means if x is 100, this thing isn't 100 million or anything like that. It's just 100, right? So this tells me that if x is really big, this is just about equal to x. Okay? So for big values of x, this gets big, but it doesn't exactly curve up. Maybe for a while it does, but ultimately it's just going to kind of be like the y equals x line, like a straight line, right? So it gets big. I'll say it gets big linearly. Now we'll talk much more about that and how you determine it. But if x is really big, that's like x times x divided by x, which is just like x. So y equals x is just a straight line. Okay? And the same over here. I'll say it approaches, y approaches negative infinity linearly. So it's like it's on a straight line and then it comes up through here and through here. But what's it going to do is x gets close to 7. Okay, well, if x is close to 7, then x minus 3 is close to what? Well, 7 minus 3 is 4, right? And x plus 2 is close to 9, right? So this numerator is close to 36, okay? And if x was 6.9, this would be maybe a little less than 36, but it'd still be close, right? It wouldn't change this numerator much. But this denominator would be what? If x was 6.9, the denominator would be negative 0.1, right? Okay, well, what do you get if you divide something close to 36 by negative 0.1?
About negative 360.
Negative 360. You can count to 36 by 0.1 in a couple of minutes. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. 1.1, 1.2, 1.3, 1.4, 1.5, 2. Right? So I'm already up to 2. It's not going to take me that long to get to 36. So you can count it on your fingers if you wanted to. Or you can know how to divide by powers of 10, right? 1/10 goes into 36, but it goes into 1 10 times, so it has to go into 36 times that many, right? And it's a negative 0.1, it's going to make the answer negative 36. So that means that if I get real close to 7, you know, not all that close, but 6.9, I'm going to be down at negative 360. Okay? Now what's going to happen if I go 10 times closer to 7? Well, then x minus 7 is going to be 10, well, x is going to be 10 times closer to 7. X minus 7 is going to be 1/10 as big. It's going to be 100th. And if I divide 36 by 100th, I get 3,600, 3,600. You can't even dig that deep. At least I don't want to dig that deep, not in this rock. Okay? That makes sense? And there's no limit to how close I can get to 7, so there's no limit to how far this goes down. Right? Well, that means I can draw this part of my graph up to x equals 7. I start out here kind of linearly, and then I probably have to, you know, do something like this, and then I just take off for the depths. That's what we mean by an asymptote. This graph never reaches the x equals 7 dotted line here, but it keeps getting closer and closer forever. Okay? So we approach negative infinity. The y value approaches negative infinity here. Now on the other side, same thing happens as we get close to x equals 7. But if we were like at 7.1, the denominator would be positive 0.1, right? So if x is bigger than 7, this denominator is always positive, right? And so is the numerator, so, and of course, it has to be because there are no zeros out here. Okay, if it's positive one place, it's positive the other, and we already figured that out. So what we get is a graph that does this. Okay, but it's got to go this way, but not right away. It's got to do this here, but it's got to do this ultimately. So it's going to come down like this, and then it's going to curve around and take off again, kind of like a straight line through the origin. Okay? Now I could go into more detail about what the graph does, and I will, since we're out of time, and since that's what I really wanted to say, that's what I'll say. So you have problems like this, and you have problems like this. I don't think I asked you to actually construct the graphs. I just, for the most part, asked you to do these signs, but this is the context, and this is what we're going to be doing. And if you understand it, go ahead and give it a shot, because you're going to have to do it eventually anyway. Okay? If I didn't assign you to draw the graphs on this assignment, I'm going to tell you to go back to this assignment and draw the graphs for the next assignment, right? Okay? So if you can do them now, go ahead. If you want to wait till the next assignment, that's fine too.